So we have sort of a curve over here, and we know that this curve is basically given to us by f of x, and f of x is equal to x squared. And so we have this curve, and what we want to do in this video is we want to find the area under this curve from x equals 3 to x equals 5. So basically the shaded area that we have over here, we're trying to find that out. In the previous video, we basically used some integration, we used some calculus to figure out how we can find this area. And we were like, okay, all we got to do is we got to sum the area of those tiny rectangles from x equals 3 to x equals 5, and we learned that we can express that in the following way. And well, in this case, if you look at what f of x is, well, f of x is given to you as x squared. And so you can kind of substitute that and get something like this. Now, what is this thing and how do we even solve it? Well, this thing right over here is a really special form that we have over here. And you need to recognize whenever you have a form in this specific symbology or this specific general structure, and I'll show you what that form looks like. This right here is the general form that you always need to identify. Whenever you see something like this, you automatically need to identify that, okay, now I'm talking about this. So you'll basically have an integral that looks something like this, where you have an x, and that x is going to be raised to some power. And whenever you have an integral like this, there's a really special way of solving this. That's why you need to be able to identify this first, and then of course you'll be able to solve it. So it basically turns into something like this. And what you do is basically you have your x raised to some power n, and what you do is you basically add 1 into that power, and then you divide that thing by whatever the power was plus 1. And then of course don't forget the limits. So your limits are basically the regions between which you want to find the area. In this case, in our case, those are 3 and 5. If we just take our integral over here, our integral was basically this thing, right? It was this integral of x squared, and the limits of that were 3 to 5. And so we're trying to solve this thing, and we can clearly see that it's in the same form as that integral up there, which is x raised to the power n. We clearly have an integral that is in the same form, so we have identified it. Now all we got to do is we got to solve it. So we know how that general form integral is solved, and since our case is similar to that form, we can solve our case as well. And we have this x raised to the power 2, so all we're going to do is we are going to add 1 into that power, and then we're going to divide the entire thing by the power plus 1. And then of course don't forget to add your limits over here. So we can simplify this thing, and it's basically going to look something like this. And now all you got to do is just apply your limits. So you see your upper limit is 5 and your lower limit is 3. So wherever you see x, you're just going to input the upper limit first, and then you're going to input the lower limit after, and then you're going to subtract those two. So that's basically going to look something like this. Once you solve this, you're going to get the area. This is basically how you solve integrals in the form of x raised to the power n. You need to identify this form first, only then will you be able to solve out integrals like this. And of course, these steps that I just showed you guys, these steps are really important. If you miss any of these steps, you're not going to get the right answer. So go ahead and practice on all of these examples, and you can take any two limits. Let's say I have the first example over here. The first practice example is x raised to the power 3. And I could take any random limits, right? I could take, let's say, 3 to 5, or I could take 2 to 10. Just take any random limit and find the answer, find the area of the curve between those limits. You don't even need to see the curve in order to do this. Even if you erase this curve that I've drawn over here, you could still apply these steps and you could still get the area. So go ahead and practice these out.